In the summer of 1997, deep in the remote waters of the Pacific Ocean, something extraordinary happened. A sound, loud, eerie, and unlike anything ever recorded, echoed through the depths. It was so powerful that it was picked up by hydrophones over 5,000 kilometers apart. This sound, later named the Bloop, would become one of the most mysterious and debated phenomena in oceanographic history. The Bloop was detected by the National Oceanic and Atmospheric Administration as part of their effort to monitor underwater sounds using a network of hydrophones. These devices, originally designed to track Soviet submarines during the Cold War, had been repurposed for scientific research. What they captured that day was a sound of unprecedented magnitude, a low-frequency rumble that lasted for about a minute and was loud enough to be heard across vast distances. The sound's origin was traced to a remote area of the Pacific Ocean, near the southern tip of South America, and not far from the Mariana Trench, the deepest part of the ocean. This location, known for its extreme depths and unexplored mysteries, only added to the intrigue. What could possibly create such a sound in one of the most isolated places on Earth? When the Bloop was first made public, it sparked a wave of speculation and fascination. Scientists were baffled. The sound didn't match anything in their databases. Not earthquakes, not volcanic activity, not even the calls of known marine animals. It was something entirely new, and that uncertainty fueled the imagination of the public. Theories began to emerge almost immediately. Some suggested it was the sound of a massive iceberg cracking and calving, a phenomenon known to produce loud, low-frequency noises. Others speculated it could be the call of an unknown sea creature, something far larger than any animal known to science. The idea of a colossal squid or a giant whale captured the public's imagination, evoking images of mythical sea monsters lurking in the depths. But the Bloop wasn't just a scientific curiosity. It was a cultural phenomenon. The sound's eerie, almost otherworldly quality made it perfect fodder for conspiracy theories and pop culture. Some even suggested it could be evidence of extraterrestrial activity or a secret military experiment. The mystery of the Bloop became a symbol of how little we know about the ocean and the secrets it holds. As we delve into the story of the Bloop, one thing becomes clear. This wasn't just a sound. It was a reminder of the vast, unexplored world beneath the waves, a world that continues to surprise and mystify us. But what really caused the Bloop? And why does it still captivate us decades later? The Bloop wasn't just a sound. It was a riddle that challenged scientists and captivated the public. With no immediate explanation, theories began to swirl, ranging from the scientifically plausible to the wildly speculative. Each theory offered a glimpse into the possibilities of what could lurk in the unexplored depths of the ocean. One of the most widely accepted explanations is the iceberg theory. Scientists from NOAA and other institutions suggested that the Bloop could have been caused by the cracking and calving of a massive iceberg. Icebergs are known to produce loud, low-frequency sounds as they fracture, and the Bloop's characteristics matched this type of event. In 2005, researchers confirmed that similar sounds, known as icequakes, had been recorded in the Antarctic. This theory gained traction because it fit the data, but it didn't completely satisfy those who were drawn to the mystery of the Bloop. Then there's the sea creature theory, the idea that the Bloop could be the call of an unknown marine animal captured the public's imagination. Could it be a colossal squid, a giant whale, or even a creature unlike anything we've ever seen? The ocean is home to some of the largest animals on Earth, like the blue whale, which produces the loudest biological sounds known to science. But the bloop was louder and lower in frequency than any whale call ever recorded. This led some to speculate about a creature even larger than the blue whale, something that could dwarf even the most massive known animals. Another theory points to geological activity. The ocean floor is a dynamic place with underwater volcanoes, earthquakes, and other seismic events producing powerful sounds. The bloop's origin near the Mariana Trench, one of the most geologically active regions on Earth, made this theory plausible. However, the sound didn't match the typical patterns of seismic activity, leaving this explanation inconclusive. Of course, no mystery would be complete without more exotic theories. Some suggested the bloop was evidence of extraterrestrial activity, a signal from an alien civilization beneath the waves. Others proposed it could be the result of secret military experiments, perhaps a new type of submarine or underwater weapon. And then there were those who invoked the mythical Cthulhu, a fictional sea monster created by author H.P. Lovecraft, as a tongue-in-cheek explanation. The bloop became a cultural phenomenon, inspiring documentaries, books, and even video games. It tapped into our fascination with the unknown and our desire to believe that there are still mysteries waiting to be solved. But as the theories multiplied, one question remained. What was the truth behind the bloop? As we explore these theories, one thing becomes clear. The bloop is more than just a sound. It's a symbol of how little we know about the ocean and the secrets it holds. And while science may have provided an answer, the mystery of the bloop continues to captivate us, reminding us that the ocean is a place of endless wonder and possibility. To understand the bloop, we need to dive into the science of underwater acoustics, a field that studies how sound travels through water. Unlike air, water is an excellent conductor of sound, allowing low-frequency noises to travel vast distances. This is why the bloop, despite originating in a remote part of the Pacific Ocean, was detected by hydrophones thousands of kilometers away. The hydrophones used to capture the bloop were part of the SOSUS, Sound Surveillance System, a network originally designed by the U.S. Navy to detect Soviet submarines during the Cold War. After the Cold War ended, these hydrophones were repurposed for scientific research, providing an unprecedented ability to monitor the ocean's sounds. The bloop was one of the most striking discoveries made using this technology, but it wasn't the only one. Over the years, SOSUS has recorded a variety of mysterious sounds, from the haunted Julia to the eerie Train. When scientists first analyzed the bloop, they were struck by its unique characteristics. The sound was ultra-low frequency, ranging between 1 and 50 hertz, and lasted for about a minute. It was also incredibly loud, louder than the calls of blue whales, the largest animals on Earth. To put it in perspective, if the bloop had been produced at the surface, it would have been audible to human ears from hundreds of kilometers away. One of the key challenges in identifying the bloop's source was its location. The sound originated in a remote area of the Pacific Ocean, near the southern tip of South America, and not far from the Mariana Trench. This region is one of the least explored on Earth, with depths reaching over 10,000 meters. The extreme pressure and darkness of these depths make it difficult to study, leaving much of it a mystery. To solve the puzzle, scientists compared the bloop to other known sounds. Icebergs, for example, produce loud, low-frequency noises when they crack and calve. These sounds, known as ice quakes, share some similarities with the bloop. In 2005, researchers confirmed that similar sounds had been recorded in the Antarctic, lending credibility to the iceberg theory. However, the bloop's unique characteristics left some room for doubt. Another possibility was geological activity. The ocean floor is a dynamic environment with underwater volcanoes, earthquakes, and landslides producing powerful sounds. The bloop's origin near the Mariana Trench, one of the most geologically active regions on Earth, made this theory plausible. However, the sound didn't match the typical patterns of seismic activity, leaving this explanation inconclusive. Despite the scientific explanations, the bloop continues to captivate the public's imagination. It's a reminder of how little we know about the ocean and the secrets it holds. Even with advanced technology and decades of research, the ocean remains one of the last frontiers on Earth, full of mysteries waiting to be uncovered. As we explore the science behind the bloop, one thing becomes clear. The ocean is a place of endless wonder and possibility. And while we may have found an answer to the bloop's mystery, it's a reminder that there's still so much we don't know. The bloop may have been explained as the sound of an iceberg cracking, but its legacy endures. It remains one of the most fascinating mysteries of the ocean, a symbol of how much we still have to learn about the deep sea. Its story has inspired scientists, storytellers, and dreamers, reminding us that the ocean is a place of endless wonder and possibility. One of the most significant impacts of the bloop was its role in advancing oceanographic research. The mystery highlighted the importance of monitoring underwater sounds and understanding the acoustic environment of the ocean. The hydrophones that detected the bloop, part of the SOSUS sound surveillance system, have since been used to study everything from whale migrations to underwater earthquakes. The bloop showed us that the ocean is not a silent place. It's a symphony of sounds, each with its own story to tell. The bloop also captured the public's imagination, becoming a cultural phenomenon. It inspired documentaries, books, and even video games, tapping into our fascination with the unknown. The idea of a mysterious sound from the depths of the ocean resonated with our primal fears and curiosity, reminding us that there are still mysteries waiting to be solved. The bloop became a symbol of the ocean's secrets, a reminder that we've only scratched the surface of what lies beneath the waves. But the bloop's legacy goes beyond science and pop culture. It's a reminder of the importance of exploration and discovery. The ocean covers more than 70% of our planet, yet we've explored less than 5% of it. The bloop showed us that even in the 21st century, there are still things we don't understand, still questions waiting to be answered. It's a call to keep exploring, to keep pushing the boundaries of what we know. The bloop also sparked conversations about ocean conservation. As we learn more about the ocean, we're also learning how fragile it is. The same technology that detected the bloop is now being used to study the effects of climate change, pollution, and overfishing on marine ecosystems. The bloop reminded us that the ocean is not just a source of mystery. It's a vital part of our planet that needs to be protected. As we reflect on the legacy of the bloop, one thing becomes clear. It's more than just a sound. It's a symbol of our curiosity, our desire to explore, and our connection to the natural world. It's a reminder that the ocean is a place of endless wonder, full of mysteries waiting to be uncovered. And while we may have found an answer to the bloop's mystery, it's a reminder that there's still so much we don't know. The ocean is vast, deep, and full of secrets. Who knows what other mysteries are waiting to be discovered?